We are from Group 2, in my topic FFB harvesting system for palm oil plantation. Let me introduce my new members. Me is Lao Jinzi, they call me Lao. He is Ayu, he is Lim Kakang, he is Lim Juan, and he is SHAMIRA. So for our introduction, traditionally, the housing process is depending on the manual labor force and a human force using the hoe to cut. So the major problem for the traditional method is the time consuming is very high and the productivity is very low. This may it also causes the economical problem on the using a human force. So the SDG has invest the digital innovation need to automate the various process, mechanization, and interconnectivity. So for our project objective, we're going to design a fresh root branch harvesting system which can increase the efficiency and productivity while reducing the labor cost of the activities. So our progress scope is able to cut and collect the FFB effectively and ready to operate for a whole day and using the electricity or petrol fuel. Statement for our project, the conventional FFB housing progress require workers with good physical strength, skill and experience. So the new design is to reduce the minimum requirement for FFB housing workers. And the design statement is based on the objective. So we need to design a FFB housing system that consists of scoping mechanism that can observe the richness of the palm oil fruit. So easy for us to cut, to identify it to cut or not. We will pass to the next person. More project. So for our methodology, starting we're going to make a research on the background of the palm oil tree harvesting system. So identify our needs, then with the discussion between the group members. So we decide the function decomposition and we do about the BTS, which is a project design specification. And based on it, we do if our members are doing out the morpho 这个 chart, based on the morpho 这个 chart, we do out the concept generation, sketches on the AP papers, and do a second selection and evaluation. Using the scoring and screening method, we finalize our design drawing. And we are going to do a CAD drawing of it and a simulation on the future. The last is the engineering analysis. We will pass by.
Next, I will present the background study. So this is the mind map that our team member made to study and gathering the information we need in our project. So the information gathering is there are five main points. So we study about the oil palm trees specification, FFB specification, economic problem, quantity harvested, and FFB cutting method. So the oil palm tree specification. So in the type of the oil palm tree invasion is the what? Oh, sorry. Next the tree. So the tree grows to around 20 and 30 meter. They may up to 100 years or more, and economic lifespan 25 to 30 years. So because according to MPOC, palm oil must be replaced with a fresh breeze every 25 to 30 years. Economic reason. So the best season of oil palm planting is from June to December. So the starting produce fruit in batch after 2 or 3 years planting. So the oil palm farm, the number of leaf on the oil palm plant increase from 30 to 40 in a year after age 5 to 6 years. The shape of an oil palm leaf can be up to 7.5 to 9 meter long. Each leaf can have from around 250 to 400 strands of leaflet. So next is the FFP specification. So this is the structure of the palm fruit that we study. So the worker have to know. So the fruit of palm tree weight between 20 and 25 kilogram. So average in one bunch of the oil palm fruit will produce 1,000 to 3,000 fruitless. So this FFP category, there are 7 type category. So the good, right, underripe, overripe. The C, empty, and damage. So the quantity of diversity. So basically, we can see from the 1916 to 2020, the more and more years, the requirement of oil palm FFP is increased. So this the cutting method. There are 2 cutting method, manual and motorized. So manual and using a motor, both is using the pole, and worker have to tilt their head, so there's problem with their neck. So this harvesting stage to worker to collect to harvest the FFP. In early stage, using a manual, and at the 6 to 7 years old, also using a manual with a pull. And next, beyond to 7 years, 3 up to 20 meters, they also use the pull, but with the motor. Next, the economic problem. So worker have to face the safety and health issue. So based on it, worker will be hit by the falling FFP and injured when using the cutting tooth and skill operation when contact with oil palm fruit, stress and long working hour, and worker also can be bite by the insect on and snake. So the caution, the cost by the cutter who have a very high level exposed at the neck and shoulder. For starter, always need to prevent his body to cut, and those operator always need to stamping and question. So this is an example of the injuring the worker will face. So, what related to musculoskeletal disorder, repetitive motion injury, repetitive strain injury, and disorder of the muscle tendon unit. Next, I will pass on.
Good morning, everyone, and doctor. So now I'm going to talk about the product design specification (PDS) for our design. In general, PDS is very important as it will limit our design and consists of the measurable criteria to achieve our objective and our scope as well. So the first criteria that we will consider is performance. So our system can be identify the brightness of palm oil and cut off the FFP within 10 seconds. This is achieved by the scoping mechanism that we visit our objective. And so the use for our system will be used on the tree with the height of 1.5 meters and to 20 meters. So the pole of our machine is adjustable to different heights. And the harvesting system of our design can be able to accommodate the FFP in the range of 5 to 25 kilograms. And because we will use our design in the oil palm gland, so we have to measure that our system can move easily in the uneven terrain. And we will make sure our system to be able to work at least 10 hours per day. So next is for the size. So the pole of our design will be 20 meters and the length and width for our machine will be approximate to 3 meters. So for the cost of our design will be maximum 8,000 ringgit, and the quantity is 1 unit for our system. So next is maintenance. So we have to measure all the spare parts for our system can be accessed easily, and the oiling is allowed because we may use some mechanical mechanism in our system design. So we also have to make sure our finishings will be corrosion resistant, and the material that we use will be light, strong, and not easily damaged by the impact, and also have good resistance to corrosion and high durability. So the product life for our design is 20 years, and our end customer is oil palm farmer or FFP harvester. So the standard that we will follow is ISO 12100, which is for safety of machinery for our design to control the risk assessment and risk reduction. We can identify the hazard and do some protect measurements maybe the safeguarding for to prevent the accidents. And also the ISO 14001, it is a international standard for environment management system because our design will be used in the oil palm farm. So the weight of our design will be around 100 kilograms, and the life of service is 5 years. And for the safety, we make sure there is not sharp projection in our design, and it's user friendly, and the user manual and instruction will be provided to the workers. So next is environment of our design. So first is uneven terrain as mentioned just now, and because we will use in Malaysia, so we'll consider the rainfall and also the temperature of in our country. So the average annual rainfall is around 2,000 to 2,500 millimeter, and the temperature is 21 degrees Celsius to 32 degrees Celsius. For the shelf life storage is 2 months, as we need to avoid any depreciations for our design due to the wear and tear issues. For the packing, we will use the standard packer, maybe with suitable walls or container. So for the time scales for our design is 15 weeks for the lecture periods. We need to form the final design with complete simulations and also some related design documentation. And the testing is because we will use CAD drawing, so we will do some simulation to prove that our design meets this PDS criteria. So for the ergonomics, it must be convenient and easy to operate and use, and can operate easily by one person. So I will pass to next person.
Good morning to all. So my name is Lim Zuan. So I will continue with the concept generation. So for concept generation, everyone has their own unique and creative ideas to solve the issue given. So by generation of different ideas, we were able to solve the problem much efficiently and more tendency to solve the issue. So for concept generation, we involve 2 stages, which is function decomposition and also morphological check. So for function decomposition, we have take the currently existing motorized cutter. So it is made up of 6 elements, which are petrol-based engine motor, engine throttle, drive shaft, changeable pole, gearbox, and kicker and cell. So the function structure of this oil pump motorized cutter is the user will start the petrol engine, and after that the drive shaft inside the motorized cutter will rotate it with the engine throttle. After that there is the linear vibration at the kicker and chisel or seeker. So after that it can harvest the oil pump. Next we go to the toe pump wheel harvesting machine. This is also an existing machine in the FFB. So there are a total of 8 elements. There are telescopic bomb lifts, hydraulic cylinder. There are also stabilizer, wheel, control room. So they have 2 important cutting tools. 2 important tools, which is the grabber and cutter. So for the grabber and cutter, the cutter will first cut the branches, and the grabber will grab the FFB, so we can avoid the FFB dropping on the ground. Yeah. So the function structure is the user will enter the control room, and the stabilizer will balancing the whole machine. After that, the crank will rotate and move to the position, and the target FFB will be grabbed here, and it will separate from the tree. After that, the crane rotation and adjustment of telescopic bomb leads to the collector. So it will collect all of the FFP that being cut into the collector. After that, we have harvested the FFP. So here is the automated FFP harvester, which is used to collect all of the FFP. So after function decomposition, we have the morphological chart. So in the morphological chart, we have included 7 important criteria, which is cutting, reaching mechanism, motion transfer, power supply, scoping mechanism, mobility, and also impact absorption. So this is the morphological chart for me. So every one of us have come up with 3 ideas for each criteria. So for cutting criteria, I have the hydraulic cutter, hydraulic chisel, and also the rotary sickle 180 degree. So for the reaching mechanism, we have 3 types, which is telescopic bomb lift, scissor transmission jack, and also exchangeable hose. After that, the motion transfer that we use is stroke doubling mechanism, hydraulic system, and also rotary shaft. The next criteria is the power supply. The example of power supply for my morphological chart is gasoline engine generator, electricity, solar panel. Well, for scoping mechanism, we have the camera with display screen, UV ray with sound, so we can detect the FFP, the right FFP. After that, we have also telescope on screen review. After that, for mobility, we have 4-wheel based vehicles, trolley based machine, or hand carry based cutter. So the last thing is for impact absorption. So this is to avoid the damage to the quality of the FFP. So for the impact absorption, I have the safety net, sponge and space plus safety net. Next we have the soft tunnel plus collector bead. So generally this is my morphological chart. So we going to next, which is morphological chart come from SIAH, and generally this is all of the figure that he has sketches. Here is for example. After that, we compile all of our team member morphological chart into one single morphological chart. This morphological chart from Lao. So in the overall morphological chart, we have filtered out the repeated sketches and compiled it into one simple overall morphological chart. So this is the overall morphological chart. Then we continue with the next stages, which is the selection of morphological chart. So we have list down the selection in the table form. So here is the example. So the purpose of this selection is to generate the different concept sketches by combining the different function criteria that we use here. So for example, cutting, reaching, motion transfer, power supply, scoping, mobility, and impact absorption. Here is the tabulated form. So after that, this is the concept generation. So the concept generation that sketches by me is mostly vehicle based. After that, here is the concept generation from SIAH. So our sketches are mainly more automated. Yeah. So next we continue with concept generation from KANG. So the sketches that provided from him are more minimize the machine, so it can more flexible to use in the oil pump area. So for next is concept generation from Lao. So Lao sketches are also more focusing on vehicle type, and he has one portable harvesting machine. So this is the concept generation from RU. So we pass to next person for SIAH.
Okay, good morning to our lecturers and all my friends. Now I would like to talk about the concept selection for our group. In this concept selection, we have 3 stages, which is concept screening by using the screening matrix. After that, we have redevelopment of the concept, and next we come to the concept scoring by using a scoring matrix. So for screening of concepts by using the screening matrix, we have the data, which is one of the concepts that's selected from our group members, and we set it as a data, and the marks is given based on the data, which is 0 mark indicates that it is equal to the data, +1 indicates it is better than the data, and -1 indicates it is worse than the data based on the criteria than this. So this is the screening matrix that's from our group. So you can see that the criteria we have is the ease of use, ease of handling, ease of verification, material use, ease of maintenance, effectiveness of harvesting the FFB, and the labor demand. So since our group is focusing on the harvesting best quality of FFB, so we put the criteria of effectiveness of harvesting FFB inside it, and also the labor demand is indicates how easier the labor use the machines and how easier it handling the machines, and beside that it also indicates good how the laborers can reduce the economic problems. This is like general criteria. So after that, in the scoring part, we have the more specific criteria in it. So after we go through the screening process, the top 5 concepts that stand out is S1 from previously we have, and A2 we have 2 marks, and K3 and A3, and finally K1. After that, we come to the redevelopment of the concept. For the redevelopment of concept, each of the members are given a task to come up with one redevelopment of concept based on the screening result of the screening previously. So this is the concept come out by Lau. Next, this is the redevelopment concept of Lim. Next is from Lim, Kaka. Next is the concept come out by me. And finally, this is the redevelopment concept come out by IU. So after we are gathering all the redevelopment concept plus the previously top 5 screening concept, we combine it and came to the scoring. In the scoring, we have data also one of the concepts that selected from this 10 concept, and the score is given with the range 1 to 5, which 1 is indicates the worst one, and the 5 is indicate the best compared to the data. So the total score for each criteria was calculated based on the formula shows the screen, which is score of the range divided by 5 and time per weightage. So this is the scoring matrix. For the scoring matrix, we have the criteria that's more specific compared to the previously screening matrix. And since we are focusing on the quality of harvesting FFB, so we give the higher weightage for quality of housing FMB, which is 20 marks, and quality of housing FMB, we have 10 marks. Since the ease of use and handling is also important in our design, so we also give it a weightage of 10 each. And then after this, the base is 5 marks, which is indicate more less important, but also so this is our scoring matrix. In the concept 7, which is the level of concept A2, we have the highest overall mark, which is 63. And the concept 4, which is the original concept from A3, which is we have 61 marks. And the top 3 concept is the concept 10, which is the original concept of A1 with 55 marks. These marks are given based on the weightage and after the discussion within the members. So now we have come to the top 3 concepts, the highest top 3 mark. And after the discussion within the group members, and we count out the final concept, which is we have the score 63, which is concept 7. And this is the final concept we have. So in this final concept, we have involved the cutting mechanism, which is by using the saw type cutter. So then we won't need to exert the force, higher force on it. We just need the rotational force to cut the branches. And also, besides cutting the branches of the fruit, we also can use this machine to pruning process to cut off the leaf. And after that, we have the white net. White net. This white net is used to avoid and prevent the FMB dropping outside of the machine area, so that the FMB can drop into the collector of the machines easily. And then we have a adjustable computer and the seat, and this is the seat provided for the workers to operate the machines. And since there is a seat, so the workers don't need to work around the farm, large area of farm, so we can reduce the physical strain needed, and or you need to just sit on the seat and operate the machines effectively. And we also have a scoping mechanism, so the workers can directly scope the right foot on the screen, so he doesn't need to lift up his head and cause ergonomic problem. And here's there's the final concept of our view. So here comes the conclusion I will have to.
So for conclusion, the final design is designed to increase the efficiency of FFP harvesting process with good quality. So it is our process idea. So